Today, I'd like to talk about the go to the moon, using CubeSats, as the opening remarks. I'm Tatsuaki Hashimoto from JAXA. I think, the moon is very far from the Earth, compared with low Earth orbit, about, 1,000 times further. But very close compared with Mars or asteroids. That is 1,000 times closer. Opportunities to go to the moon will likely increase in the future. This is my story for the moon exploration. 2000s, I had been in charge of a large-scale lunar exploration mission like that, lander, rover, and orbiter system, a very large-scale lunar exploration mission. But unfortunately, we could not receive the budget because the budget was very big. 2015, NASA offered opportunities for ride-share CubeSats on Artemis 1 rocket. So I proposed a moon landing mission, Omotenashi, outstanding moon exploration technologies demonstrated by nano-semi-hard impactor. Conditions for secondary payload at that time by NASA is, first, its mission should include science and technological goals that advance human exploration, because Artemis program is basically a human exploration program. And its size should be within 6U size, and its mass should be less than 14 kilograms, very small spacecraft. And the launch date at that time was 2018. So it means that a very rapid development was needed. And it was to be put into lunar flyby orbit, but no detailed trajectory information was provided at the invitation time. And the safety regulations were those were crewed vehicles because it would be co-launched with Orion spacecraft, a manned spacecraft. So we proposed such kind of mission first from the development of from SLS rocket, attitude control for pointing sun, and the next day of the launch, we will control the spacecraft to lunar impact orbit. And finally, just before reaching the lunar surface, a small solid rocket motor will be ignited and decelerate. And finally, to compensate the residual velocity, that will be about 50 meters per second, very high speed. So we prepared the shock absorption system for the spacecraft. And also we planned to measure the radiation environment during this sequence. So that means so-called smallest moon lander in the world, launched by the most powerful rocket in the rocket. SLS Space Launch System is the biggest rocket in the world. So 2016, the Omotenashi mission was selected by NASA, and we had started the development of the spacecraft. And 2021, the CubeSat was successfully developed and handed over to NASA. The configuration of the spacecraft is like that. And that is a photo of the handover to NASA at Kennedy Space Center. that is a final check of the spacecraft, and this is a final, how can I say, assembly of the spacecraft, because we have the small solid rocket motor, but solid rocket motor was kind of a dangerous thing. So we transported the solid rocket motor separately to Kennedy Space Center, and integrated finally at the Kennedy Space Center. And that is a photo of Orion stage adapter. Ride-share spacecraft, the ride-share CubeSats were 10 CubeSats like that. And there are several delays of launch, but finally the CubeSats were launched in 2022 years. That is a photo of the launch, 2022 November 16. But unfortunately, our spacecraft failed the initial sound acquisition control, and finally its battery was depleted. And since then, we have not we have not been able to communicate with CubeSat. Measuring of radiation environment was successful. That was only 30 minutes, but we could get very important data of the radiation environment. Okay, so that is the summary. Unfortunately, our Omotenashi had to give up the moon landing experiment. However, we could develop some technology for we proposed a semi-hard landing scheme, and that was confirmed by the ground test. And Omotenashi successfully measured the radiation environment outside Earth's magnetosphere. That is very important for the future human exploration. It was measured by a very small, ultra small sensor, about a 50-gram sensor. And currently, the success rate of the spacecraft is not so high in case of the CubeSat. It will be a hard job to develop, but the opportunities are extremely variable, I think. And onboard opportunities of not only CubeSats, but also small observation instruments are expected to increase from now. Today, some speakers talk about that. So, for example, NASA proposed Artemis program, and some nations join that program. So, there are many share onboard opportunities, I think. So, the summary. Let's take on the challenge of go to the moon. Thank you.